tired of struggling with complex inheritance structures in your Django applications? Do you want to take your web development skills to the next level and create more dynamic and powerful applications? Then this video is exactly what you need. In this informative and engaging video, you'll learn everything you need to know about Django model inheritance, from abstract models to multi-table inheritance and proxy models. You'll gain a deep understanding of how to implement these concepts in your web development projects. Whether you're a beginner or an experienced developer, this video is perfect for anyone looking to expand their knowledge of Django model inheritance. So, you ready to become a Django model inheritance master? Then don't hesitate to check out this video and start building better, more complex, and more dynamic applications today. Model inheritance in Django works almost identically to the way normal class inheritance works in Python, but the basics should still be followed. That means the base class should subclass django.db.models.Model. The only decision you have to make is whether you want the parent models to be models in their own right, or if the parents are just holders of common information that will only be visible through the child models. There are three styles of inheritance that are possible in Django. Often, you will just want to use the parent class to hold information that you don't want to have to type out for each child model. This class isn't going to ever be used in isolation, so abstract base classes are what you're after. If you're subclassing an existing model, perhaps something from another application entirely, and want each model to have its own database table, multi-table inheritance is the way to go. Finally, if you only want to modify the Python level behavior of a model without changing the model's fields in any way, you can use proxy models. Let's start with abstract base classes. Abstract base classes are useful when you want to put some common information into a number of other models. You write your base class and put abstract equals true in the meta class. This model will then not be used to create any database table. Instead, when it is used as a base class for other models, its fields will be added to those of the child class. Let's create a new Django project which will be used to explore this inheritance concept. Open your terminal or command prompt and navigate to the directory where you want to create your project. Run the command django admin start project name, where project name is the name of your project. This will create a new directory with the same name as your project and a few files and directories inside it. Create a new app inside your project by running the command python manage.py startap blog. This will create a new directory called blog with some files inside it. Open the settings.py file in your project directory and add blog to the installed apps list. Run the command python manage.py migrate to create the necessary database tables. To test your app, run the command python manage.py run server and open your browser to this URL. This should show the default Django welcome page. Now, you can start building your app by defining your models in the models.py file inside the blog directory. Let's say we have several models in our Django project that all represent different types of content, such as articles, blog posts, and news items. These models may have some fields in common, such as a title, content, and date. Instead of duplicating these fields in each model, we can define an abstract base class that includes these common fields, and have each of our content models inherit from this base class. Here's an example of how we can use an abstract base class to define common fields and methods for a set of models representing different types of content. So, the purpose of this code is to define models for a website's content, such as articles, blog posts, and news items. At the top of the code, we import some necessary modules from Django that help us define our models and generate slugs. Next, we define a base model called content base that contains common fields that are shared among all types of content, such as the title, content, and publish date. This base model also includes a slug field, which is used to generate a unique role-friendly identifier for each piece of content. We also define a save method that generates a slug based on the title field and saves the instance to the database. Now, here's where things get interesting. We set the abstract attribute of the meta class to true, which means that this base model cannot be instantiated directly. Instead, it serves as a template or base class for other models to inherit from. We then define 3 different models that inherit from content base: article, blog post, and news item. Each of these models adds its own unique fields, such as the section field for articles, the tags field for blog posts, and the location field for news items. By using inheritance in this way, we can avoid repeating common fields and behaviors across multiple models. This makes our code more maintainable and easier to understand. This time, we're looking at how we can use the built-in Django admin site to manage our models. At the top of the code, we import the models we defined earlier: article, blog post, and news item. Now, get this. We use a decorator to register each model with the admin site. That's right. We just add a simple admin.register decorator before each class definition, and bam, Django knows that we want to display this model in the admin site. But wait, there's more. We also define a custom admin class for each model by creating a subclass of admin.model.Admin. This allows us to specify which fields we want to display in the list view of the admin site. In this case, we're displaying the title, section tags, location, and publish date for each model. And that's it. With just a few lines of code, we've made our models easily manageable through the Django admin site. Pretty cool, huh? Open up your terminal or command prompt and navigate to the project directory. Run the command python manage.py make migrations to create migration files for any changes you've made to your models. Run the command python manage.py migrate to apply those migration files to your database. If you haven't already done so, create a super user account by running the command python manage.py create super user. Follow the prompts to enter a username, email, and password for your super user account. Now, it's time to run the server. Run the command python manage.py run server to start the development server. Open up your web browser and navigate to admin link. This will take you to the Django admin site, where you can log in with your super user account and start managing your models. When we log into the admin site using our super user account, we will see a list of all the instances of these models that are currently stored in the database. If we click on one of the instances in the list, we will be taken to a detail view that shows all of the fields for that instance. We will be able to edit any of those fields and save the changes back to the database. We can also delete the instance if we no longer need it. Now, when it comes to abstract model inheritance, one of the key features of Django's admin interface is that it recognizes the inheritance relationships between models. Since article, blog post, and news item all inherit from content base, Django will display the fields from content base in the detail view for each of these models. This means that we can still access and edit the title, slug, content, and pub date fields for each instance of these models, even though we did not explicitly define those fields in the admin class for each model. Meta-inheritance. Did you know that when you create an abstract base class in Django, any meta inner class you declare in the base class will be automatically made available as an attribute? And if a child class doesn't declare its own meta class, it will inherit the parent's meta. But that's not all. If the child wants to extend the parent's meta class, it can even subclass it. With this powerful feature, you can easily define common metadata for all the models that inherit from your abstract base class, and also have the flexibility to override and add new metadata as needed in your child classes. Before we delve into the exciting world of meta inheritance in Django, let's talk about something equally important: populating our database with some initial data. We can do this easily using fixture data, which is essentially a JSON or XML file containing data in a predefined format that Django can use to populate the database. But, hey, if you're not quite familiar with the concept of meta classes in Django yet, don't worry, I've got you covered. You can check out my previous video where I explain everything you need to know about Django's meta class in a fun and easy to understand way. Now, let's get back to populating our database with fixture data, shall we? Create a new file named initial-data.json in your app's fixtures directory. If it doesn't exist, create it. In the initial-data.json file, define an array of objects, where each object represents an instance of one of your models. Note that if you make changes to your models and want to update the initial data in your fixture, you will need to create a new fixture with the updated data and load it into your database again. Once you have created your fixture, you can load it into your database by running the command python manage.py load data initial data.json. Run the server and navigate to Django admin interface link in your browser to check if your data are there. Alright, folks, now that we've pre-populated our database with some initial data, let's explore what we can expect to see in the Django admin interface. We've got a list of articles, blog posts, and news items, each with their respective titles, sections or tags, locations, and publication dates. Now, here's the cool part. We're going to use the publication date field to explain the meta inheritance concept in Django. So, pay close attention to that field in the admin interface. Trust me, it's going to be exciting. When you create an abstract base class in Django, any meta inner class that you declare in the base class becomes available as an attribute. This means that any child class that inherits from the abstract base class can use the meta inner class that was defined in the base class. If a child class doesn't declare its own meta class, it will automatically inherit the parent's meta. But if the child class wants to extend or modify the parent's meta class, it can do so by subclassing it. So, how does this apply to our previous models? Well, since we created an abstract base class called ContentBase, any metadata that we defined in its meta inner class is automatically available to its child classes. For example, let's say we want to add ordering, verbose name, and verbose name plural to all models that inherit from ContentBase. We can do this by defining an ordering, verbose name, and verbose name attributes in ContentBase's meta inner class, and all child classes will automatically inherit these attributes. Get ready to be amazed. Refresh your browser and witness the magic of Django's meta inheritance in action. As you do so, you'll notice that all the child classes have automatically inherited the verbose name and ordering of the base class. Here's the coolest part. We can continue to benefit from the meta attributes of the base class in each of our child models. For example, in the article model, we take advantage of meta inheritance by subclassing ContentBase.meta and customizing the verbose names to be more specific to the article model. This allows us to further streamline and optimize our code. After refreshing the admin interface, you'll notice that the article model now has its own specific verbose name, thanks to the meta inheritance we set up. Now, let's apply the same meta inheritance to our other models to improve their admin interface as well. We can also override the ordering of the base class in the news item model using meta inheritance. Just like before, we'll subclass ContentBase.meta and override the ordering attribute to order news items by their location attribute. Just refresh the page again, and you will notice that we have changed the ordering of model.